Hi, it's Mr. Benson here on behalf of the Year 9 Maths team with the first of our lesson videos, and this one is on area. So each video will have a page like this at the start where we just detail where you can find information in the textbook and that sort of thing. So our topic is area. Now in the text that is chapter 12 part 3 on page 430. So what the required knowledge and skills are is to know and understand the different formulae for finding area of a given shape and use this to work out composite shapes. And then we'll have some exercises that you can complete, including some extension stuff. Now, if you have any concerns or problems, then you should email your maths teacher as your first point of contact there. So what do we mean by area? Area is the size of a surface. Now this could be the area enclosed by the sides of a two-dimensional figure like this triangle. So that would be the area that's now shaded in blue. Or it could be the exterior surface of a 3D shape like the cube. Now when we're thinking about area, we're really considering how many squares it takes to cover a figure. So if we look over here on the right, we've got this little square which has 1 centimetre on the right side, so therefore it must also be 1 centimetre across the width of it. So the area enclosed by that square is going to be 1 square centimetre, or we would write 1 centimetre squared. When we're thinking about larger shapes, essentially all we're doing mathematically is thinking about how many squares fit into that shape. And so it's nice and easy with this rectangle over here, where we've got a side of 3 centimetres on the right and another side of 4 centimetres at the base. So 3 times 4 gives us an area of 12, and they are again square centimetres, so it is centimetres squared in the area there. The units of area are the units of length squared, as I've already sort of mentioned. So if you think about our units of length, so we've got our metre is our kind of standard unit of length. So the corresponding area is the metre squared. And then we can also have, as you've seen, centimetres squared. We can have millimetres and millimetres squared. We can have kilometres, and we can have kilometres squared, and that kind of thing. So converting between units of area, we've just got to be a little bit careful with this, because the units are squared, it means the conversion must also be squared. So we're used to the idea that, 1 centimetre equals 10 millimetres. And so what that means is that 1 centimetre squared, now remember we had a conversion here of multiplying by 10, so we've got to multiply by 10 squared, which is going to be 100 disappeared, millimetres squared. And sorry, my table was meant to pop up earlier there. So here are our conversion factors. You can just see that they're multiplying or dividing by the same values, but we're squaring them. So millimetres to centimetres is a factor of 100. Centimetres to metre squared is a factor of 10,000. Metre squared to kilometre squared is a factor of 1,000,000. One common unit of area that we will come across is the hectare, which is 100 metres by 100 metres, so 10,000 metres squared. It's just another one that you will see. So just a couple of quick examples on what we can do with this. Now you can either just think about the length conversions and then square them, or you can look back at the previous table, however you want to do it. So how many square millimetre in a square metre? Well, there's 1,000 millimetres in a metre, so it means I'm going to have to multiply my 1 square metre by 1,000 squared, which is 1,000,000, and so we're going to end up with 1,000,000 millimetres squared in a square metre. How many centimetres in a square kilometre? So again, we're going into fairly big numbers here. So there's so we've got 1 square kilometre multiplied by, so we've got 1,000 metres in a kilometre, and we've got to square that, and we've got 100 centimetres in a metre, so we've got to square that as well. this is getting ridiculous. And so we're going to have, what's that going to be? It's going to be 1, 0, 0, 0, 0, and about 6 more zeros. There we go, centimetres squared in a square kilometre. And then we might need to think about some questions where we've actually got to do some calculations and convert them as well. So a typical house block is 15 metres wide by 45 metres long. What is that in hectares and square kilometres? So my first step I would think about is multiplying my areas to find out what multiplying my lengths there to find out what the area is. So I'm going to go 15 times 45, which is 675 square meters. And then I've got to convert this into hectares and square kilometers. So my area I'll just write AH for hectares. So I've got 675 square meters. And from the previous slide, there is 10,000 square meters in a hectare, so I'm going to divide that by 10,000, and so I'm going to get 0.0675 hectares. And if I'm doing this in terms of square kilometers, I would just be dividing by 1,000,000 instead. So area in kilometers squared is going to be 675 over 1,000,000. And so I'm going to be ending up with 0.000675 kilometers squared. These are slightly silly examples, of course, because they kind of highlight why you don't use the inappropriate units. So we don't talk about the size of your backyard in terms of, hectares or square kilometers or something like that, because it's just not a very useful unit to talk in. So moving on to using formulae to calculate area. Now you will become familiar with some of these formulae, and you probably already are for shapes like rectangles and squares and maybe triangles and circles, but these are things that you should put in your notebooks and on your reference sheets so that you're not really struggling to remember a whole lot of formulae, but you just have the information that you need at hand. So starting off with the simple ones, so the rectangular shapes. Now really squares are all rectangles, so as long as you've got the idea that it's the length times the width, that will be fine. The only thing you do have to keep in mind is sometimes you'll get asked questions where recognizing that A equals L squared might be useful, because you can just then take the square root of A to get the value of L and that sort of thing. So being familiar with the formulae is good, but just make sure that you've got them written down. Now, parallelograms and trapeziums are basically just analogous to rectangles, if you like, in terms of the formula. So obviously they look different and they're not rectangles, but the way we calculate them is much the same. So the parallelogram is just the base times the height, so it's just a simple multiplication. The trapezium we are taking essentially the average of the side lengths and then multiplying that by the height. So again, we're treating it kind of like a rectangle. When we get into triangles, this is where our formulae first start to get a little bit more complicated. So triangular shapes are always half of a rectangular shape. Sometimes it's not obvious, but that's always true. So our area of a triangle is always half of the base times the height. Now it doesn't matter what shape your triangle is, as long as you know the base and the height. So the example on the right hand side where the height is not actually in the triangle, but as long as we know it, our formula is still going to work. Now if we don't know the height, then maybe we might need to use trigonometry or something like that in order to figure it out, but that would certainly be a slightly more complex question. When we get onto kites and rhombuses or rhombi, I don't quite know, again, they are essentially based on triangles, which are half of rectangles. So if we know the total length and the total height of the kite or the rhombus, then we multiply those two together and halve it, and we've got the area of our shape. And so the circle is the special case where we go into something that's kind of different. So we've got to use pi whenever we're doing calculations with circles. Now remember that there is always a pi button on your calculator that you should use. The reason for that is that your calculator stores pi to quite a large number of decimal places and will give you a more accurate answer than if you're just, putting in 3.14 or something like that. So the area of a circle, pi r squared. When we're thinking about composite shapes particularly, we're often going to have parts of circles. And it's just that if you've got half a circle, then the area of the circle will just be half of pi r squared. And we can actually go a little bit further with that as well. So if you've got an angle of, of theta, so we've got a circle, or part of a circle rather, sorry, this is going to be a hideous sketch. So we've got some kind of weird Pac-Man looking thing like that, where we've got our angle theta here. So remembering that 360 degrees makes up a circle, so the area of our, our part circle here is going to be theta over 360, so that's the fraction of the circle, multiplied by pi r squared. So yeah, if you come across anything that is not a simple fraction like a half or a quarter or something like that, if you know the angle, you can always figure out what the area is of part of a circle. I'm going to end this video here so that we keep it under 15 minutes. I'll try and do that for all the videos so that they're relatively short, but you might find that for some lessons there might be a couple of videos that you need to look at, but I'll try and break them up into sensible sort of chunks, so that with this one you were just really looking at the formulae for particular shapes, but in the next one we're going to look at how we apply those to find the area of composite shapes.